who are listening to this presentation, and I see with pleasure about 35 attendees, so a lot of interest, and thank you for joining and taking the time for this first presentation. It will be in a series of 3 parts, and the first part is more or less orientated or related to radar data. But first, many of you may not know myself, and therefore a short self-introduction for myself. And you see here a rather old picture. I have to be serious here, or reliable. It is 14 years old now. In the meanwhile, my wife and myself married since 35 years. And I have also some hobbies. I like to travel, play piano. You can see here it's in the western parts of the United States. It was an old piano, and I, did some improvisations. And also interesting for me, astronomy, history, games, and taking photos. And here that is in Patagonia, the Perito Moreno Glacier, but also 2004 in January. But I have also a professional life that is maybe most interesting for you. I studied at the University of Cologne. My diploma was already 1984. You can imagine that I'm not far away from my retirement. PhD 1990 in parallel to the so-called preparation to become a civil servant, Referendarzeit oder time. And I'm at the DWD since 1985, first research department where I did also my PhD. And then after the examination, after the referendar time, I was in the central forecast unit for about 4 years. And then moved to another part more in relation to research and development, world weather forecast, and also nowcasting. But I'm also working here at the Meteorological Center, Training Center in Langen since end of 2001, so a very long time. And my main working field is advanced training, international cooperation, project management, e-learning. And I'm also the head of the examination board for diploma every second year in principle, dean of the University of Applied Science, and the deputy chief of the training center. So that is very fast about myself. But the main work and also contributions is done by the SINFONY project and the many people who are involved in that. SINFONY means seamless combination of nowcasting and numerical weather prediction in principle. And the slides are from Dr. Ulrich Blag. He is the chair of the project. And if you have also some very special questions, I will do my best to answer questions, but sometimes it might be necessary that I relate you to Ulrich Blag, and therefore I have added the his email address. This is a very big project. You can see, I'm not quite sure if I counted correctly, 41 people, mainly by time contract, are working since more than 4 years in the meanwhile for this project, and there will be also something to do in future. Sometimes they are even more active in this field, and it is a pilot project. It will last some years, not many years, but some years, till all is worked out and is working in routine. So we are on a good way, but it is still in development. That is the meaning. Sorry for this, I was a bit confused. Seamless integrated forecasting systems. That is the meaning of the abbreviation SINFONY. So, seamless integrated forecasting system, sometimes repeated. SINFONY is the abbreviation, and seamless means that you have a smooth transition from forecast for minutes to hours. presently we have a gap from nowcasting to the numerical weather prediction area. You will see afterwards a little bit more about that. So that is the aim. And so we have presently here a coupling. We try to do it, not yet established, but it will be available at the end of the project. We have one branch, this is nowcasting precipitation, and then second branch be very short range numerical weather prediction up to 12 hours. And it is the plan to have an hourly forecast available for up to 12 hours, the so-called rapid update cycle, RUC, and that should be available from summer 2022. So that is still in development. I will more concentrate upon the nowcasting part in relation to radar, and Uli Barak will more consider the numerical weather prediction part. So the development is based here on a rather long time period with summer convection that was on 26th of May to 25th of June 2016. And you can see one convective situation after the other is here moving over Germany, more or less heavy, and so here you can see very small here the day and the time, and so that was the basis for developing the forecasting technique, and it's also long and a very happy situation that we have 1 month with many convective situations over Germany, because we need here also our radar system, and so therefore we have to consider Germany and no other areas. So now, what is presently available? We have every 5 minutes now. In the meanwhile, radar detections, and presently I can jump a little bit further. We have here the precipitation scan, but we have also other levels, and of course there are also consideration of the obstacles, topography or so. And sometimes I will go to the smartboard. In that case, you cannot see me because I have to walk outside the camera. So be not surprised when you have here a wall afterwards when I paint something in these slides. But I think that is more interesting for you. So presently we have here the precipitation scan. You have also here to consider obstacles. The angle is not constant. So that is the integration.
Wilfried, we don't hear you.
And that is already considered as in many other services. And if you have overlapping domains here, for example, the maximum value is used in the precipitation scan, but we have also different measurement angles, and that is also included in other form of nowcasting of radar features, and that will be explained later on to you during the last slides. So presently only two-dimensional structures. And that is a problem. You do not have information here from the upper levels. So relevant aspects for forecasting summer convections. Some may know this, but just for repetition, what you need are excellent observations and measurements, and also surface observations and temperature, humidity. You need also, for example, radio soundings, but also here, I have to put that away here. Besides ground measurements, also radar, satellites, and lightning detection. I will explain later on a little bit how they are incorporated in the weather prediction analysis. So here, yeah, and as detailed as possible. You need also the ingredients, yeah, like tape, humidity, wind shear, and other things. And the nowcasting is based upon observations and measurements. The numerical weather prediction are not so good to use for them because they need more time till they are available. You will see afterwards. And then you can also derive motion direction by considering, for example, circular structures and combine them in the following way. Let's take here the cell, in -5 minutes, and then here T0, T0, sorry, and then here we have to do the forecast. I hope you can read my writing. And the question is now to relate this here, and the question is first, the distance. Means distance. And then also, the attributes, for example, the amount of DWD value, for example. Then also, how big is it? So, okay, I do not know what is the meaning of this here. And then, if you have two cells that are connected to you can see here 5 minutes before and here presently, and you say, okay, that this is the same cell, then you can, calculate here, for example, some forecast. Sorry, it's a little bit interesting when I have, we do not hear you.
We have a problem with hearing you. It's like your microphone switched. It is very quiet.
Yeah, my computer is okay. Yeah, I'm a little bit surprised. My computer is working. I can hear.
It is when you walk to the board, then it is a bit quiet.
So there's something to do when I'm walking. That is interesting. Okay, then I have to sit more. Yeah, do not understand. Okay, now maybe. So now you can hear me again. Top stuff. Yeah. Computer. Sorry for this. Yeah. Okay. Good. Then I will continue. Sorry for this inconvenience and a little bit confusion. So, I will put that away, and then I will sit more, that is not so good. Sorry. Okay.
Wilfried, if you put your mic a little bit away from your mouth.
Yeah, then you cannot hear my breathing, gleich. Yeah?
Exactly. Thank you.
Yeah, okay. Yeah, thank you for these things. So, then you need for NWP model forecasts. I will make that rather briefly because that will be more done during the next presentation by Uli. But you need sufficient spatial resolution, good model physics, clear. And again, you need very good information about the beginning, the ingredients and so on. In principle, you should you know this. And then ensemble forecast, that will be more explained also for nowcasting, yeah, during the next slides. So I'll put a little bit the velocity up, yeah, and then I will be again in time. We have two forecasting methods for the next forecasting up to 12 hours. And presently, pure deterministic and very quickly available. Here you have the measurements, and here the so-called optical flow, what I try to explain here on the smart board with the relation of two consecutive images, one from the past 5 minutes before, present situation, and then to derive a forecast from these two images. And what you can see here in principle, that it is very difficult here, for example, to have the correct forecast here. It is no developed, maybe a little bit extending, because the motion vectors can be not parallel, and that will cause a little bit smaller or bigger cells during the forecast. But the development, or even a new or a weakening and then intensifying, that is very difficult to cover, and the development of new cells will not be covered, and also the decaying, dissolving of cells is also not considered presently, and that is not the way out to have such a good forecast. And that is the problem that have to be solved here during the SINFONY project. We have also very short range numerical weather predictions. The resolution is presently 2.2 kilometers. We have also ensembles, but the problem is it is available only after 1 to 1.75 hours after the starting time, and it is started every 3 hours. The aim is till summer 2022 to have such a run every hour, and also faster available. So, and what you can see here on the right side is the deterministic Cosmo DE. We have now since 2018 and Cosmo D2 model is a little bit more spatially resolved, but here the development 2016 was based on Cosmo DE model. And here are the corresponding measurements. You see big differences. You have only the possibility to consider bigger features and not small scale features, and that will be considered later on. That is one approach to have more reliable forecasts. So, but NWP and radar presently not connected to each other. So we had the principal problem that we have a gap between here the nowcasting domain based upon radar and then the numerical weather prediction. So what you see on the left side of this image is that is a nowcasting for 2 hours, started at 13:15 and valid 15:15. And then here, the numerical weather prediction start at 12 and it's also valid for the same time. And that is here from the so-called DWD app Warn Weather. And you can have it on the smartphone. Then here you see, for example, inconsistency. Yeah, here's a cell, here not, or here, the precipitation area here comes to an end. So we have a jump and gap, sudden change here from nowcasting to NWP. And the one goal of SINFONY is to have a smooth transition. So, idea of concept of SINFONY. I will present that step by step. We have forecast time, not typical for maybe 2 hours or so, as you like, or even longer. Then we have verification score. In that case, 1 is ideal. That means, for example, hit rate or correlation or what you like, as higher as bigger. And now the nowcasting presently as we have it at the beginning of the forecast, it is relatively good, but it is the forecast skill is reduced very fast during the next few hours. Then we have also the numerical weather prediction, and it is starting from the past, and then we have an analysis around the starting point. At the beginning, nowcasting is better. Later on, numerical weather prediction is better, but on a low level because the forecast of convective cells with numerical weather prediction model is normally really bad, and so you will not have a good outcome. So then when you improve nowcasting method, there are different possibilities. Radar-based principle, precipitation only is considered. You have first the field distribution of the precipitation, but you can also define so-called cell objects with attributes, for example, hail size or gusts, or is it rotating? How much precipitation within a fixed time period, and so on. This is connected to so-called cell objects. And then you can improve the method that is presently done, and then can also use ensemble forecasting methods that will be explained to you afterwards, because that is really new that we have an ensemble of nowcasting based upon radar measurements. The method itself, of course, you can, for example, improve the extrapolation method, or you can put a life cycle on it. You can also derive maybe better pixel attributes from via a better ZR relation, for example. So you can improve the method itself. Then, very important is the predictability. And as smaller the convective cells are, as more difficult are they to predict. And there is a trick, what I will explain afterwards to you, how to cover this more or less. And then, what is also now in development, we do not yet have the tendencies of cells, so intensifying, decaying, or dissolving even. And so that is also superimposed to the other parts of the forecast, as you will see near the end of the presentation. So then we have the improvement of the numerical weather prediction that will be explained more in detail mid of June probably. So more resolution, better physics, for example. Then more often started every hour and up to 12 hours. Rapid update cycle, that is the meaning of the RUC, and also a higher resolution. But I will not go too much into details because Uli will do that in mid of June. And then assimilation of new data. For example, satellite data, I will see it, I think so. Volume scan. Then the radial wind, then reflectivity, and also cell objects. So with some attributes and the shape, and also some attributes what are connected with the cell. And then also, in the meanwhile, Meteosat images and tests are running presently in relation to the solar channel. ER not yet, but work is going forward. But first tests are done with the solar channel of Meteosat. And then that is a difficult thing to have here lightning. That is an idea, but not yet realized, and no tests so far. So, And then you have the combined projects, and that is the new thing what we will have later on when the core project is near the end. You have the numerical weather prediction branch, and then you have here the nowcasting, and you do the best to have the best solution for warnings, and also verification, of course, root mean square error, median distance error, and so on. Yeah, and also the attributes of the cell can be verified. So that is what the group is doing, and day for day, and that is a long road till SINFONY is perfect. So now, step by step, also a longer presentation about this slide. We have on one branch data, three-dimensional radar, Meteosat second generation, lighting. That is concept, not yet all realized. We have the three-dimensional radar, MSG, only solar channel, and lightning, not yet realized. So first, also here from the satellite, conventional data, radio soundings, surface observations, and then I will explain later on what is meant with GPS humidity and also other satellite data. So that is again a way, and now we go here through the cell identification. What I explained here with the cell border, where is the center of the cell that can be calculated, and then the cell motion by tracking, what I explained with the T-5 and the present time and the forecast that is derived, that is the so-called tracking by cell motion vectors. And then that will be explained afterwards. We have also a nowcasting. So what we can do in principle, you can change slightly the conditions. For example, we have a threshold of more than 46 dBz, that it is a convective cell that is fixed, but we can also change it a little bit. Yeah? Or we can also change the movement of the cell by incorporating the wind direction and speed velocity in 700 to 500 hectopascal. And so when you slightly change it a little bit, then also the cell motion will be changed a bit. So that is, there are 2 or 3 ideas how you can do ensemble nowcasting. ENS is the meaning ensemble nowcasting. So 5 minutes later, you have again a cell identification, and then here cell identification 5 minutes before. And then also here an additional information, where was the forecast? And what is here checked in principle is first the distance between 2 cells. Are they not too far away from each other? Otherwise you would move too fast simply. Then other criterion what is used is the forecast position is that similar to the measurement. That is in second question what has to be answered, and then a third one is also the size and also the dBz values. So and then it is automatic combined, and then the cell motion, the tracking for the next 5 minutes is done. So and then again ensemble nowcasting, and finally you have here a set of up to 40 members of ensemble nowcasting. Only the branch of the radar. So 5 minutes again. Now we have here the numerical weather prediction. As first analysis 1 hour before the starting point or starting time. Then we have the numerical weather forecast, numerical weather NWP prediction is the same, the first guess. And then what is done now is to include here radar, satellite, lightning. So I have here written the word forward operator, and the problem what has to be solved is that you have to translate dBz in forecast parameters of the numerical weather prediction. You can imagine what you will do when you are driving in China and you have signs in Chinese. Yeah, you will not react because you cannot read it. And the same is the case for the numerical weather prediction model. DBZ cannot be understood by the model, but water content, ice content, snow content can be understood. So what is done is forward operating from DBZ values to water content, snow content, ice content, and that could be superimposed to the first guess field of the numerical weather prediction. Similar can be done for satellite and lightning. So what is then done? You have now an influencing here of the numerical weather first guess by the radar measurements, but translated to water content and so on. And then after the adapting of the first guess, it is translated to the DBZ, then compared to the radar, then the correction has been done, and then translated back to the numerical weather prediction in form of water and snow content and all the other things. So then we have here analysis, and then it is the starting point. You can also change a little bit the physics and also a little bit the starting values, the starting fields, and then you have again an ensemble forecast of numerical weather prediction that is already available in our service and many other services, I guess. So, and so on, yeah, that is done. And so you have two branches here, first from the radar ensemble, Nowcasting ensemble, then here's the ensemble from Cosmo D2 forecast or Cosmo DE 2016. And then the big thing is now to combine this. That is not yet started, and our first ideas, and that is the main task of the SINFONY project, to combine, for example, here the adapted forecast field with here objectives from cell objects here from the cell identification, or to have simulated cell objects, and you put all together here via a forward operator, also that is a translator between DBZ and water content, for example. And so these things are all combined and are working together. And that is a big task that has to be solved during the next, I hope, few years. Yeah, then here, the ensemble nowcasting is also influenced to some extent. I do not know the details because this has to be developed. So also numerical weather prediction can influence the ensemble nowcasting based upon radar data. And then finally, you have a three-dimensional picture. The fourth dimension is the time. And then these combined project from this here and this and put together, that is the final purpose, the final aim of SINFONY. And that is the best technique what you can imagine for having input for warnings and these things. It is a far way. What we in principle have is this one here. And then also here the numerical weather branch with radar data, optical, solar channel, but the others have still to be done. What is not yet available, what has to be will have to be developed, is here the combination of these two branches. So in order to have here the final project that is the best solution for warnings, what you can imagine. But it is a long way of verification and developing and testing. Therefore, the project is not yet over. At the end of this year, November, end of November, Ulrich Blag will give to you further some presentation about further development and maybe future plans. So yeah, okay. What you will see after, sorry, sometimes I forget what is coming in the next clicks here. the life cycle is also in development. We will see afterwards how that is incorporated into the ensemble nowcasting. And then, of course, verification, as I mentioned. So, just very briefly, what is meant with GPS humidity. So, I try to stay up, and I will be careful here with my connection. Yeah. So, because that is a little bit satellite meteorology. You have here the GPS. So the position is well known. And here is a low Earth orbit. Yeah, that is a polar orbiting satellite, for example. So what is done now? You have here the beam from the GPS, and then it's refracted. And then the satellites, the low Earth orbit satellite, will see the GPS here. Yeah, it's overemphasized, of course. So, and then derived here from this angle is a profile and humidity. In the upper atmosphere and till the mid of the troposphere. So that is the GPS humidity, yeah, in principle. I hope you understand my good painting. It's also not satisfying at school, you can see here. So that was a jump here to satellite meteorology. So what is focus on research? Sometimes now repetition. Ensemble nowcasting, ensemble numerical weather prediction, as already explained in the slide before. Then warning conditions. A heavy precipitation is considered presently. Then main application field, of course, a warning process at DWD, flooding, according warning. Then we have first results, combined product precipitation, and then also reflectivity and the objects of convective, the object's convective cell. And yeah, there are also some special versions in testing and development. A visualization in NINJO, that is our working system and partly also used at other services. And then now what is here? The radar nowcasting. So that is now here the next main topic what I would like to explain to you. So we have here is a little bit difficult to see different members of the ensemble, number 10, number 20, number 30. Yeah? And if you have time enough to consider this, you will see there are some differences. And the question is now, how is that prepared? Presently, we have composites, radar pixels, reflectivity and millimeter, optical flow is there, yeah, movements analysis. Then we have the deterministic and linear extrapolation and also ensemble. New is now considering the uncertainties, because you have here a forecast of very small cells, but they are probably not correct. So that would confuse the forecaster, and the idea is to remove them from the forecast. You will see afterwards how that is done. So then growing in decaying will later be explained, as you can see here. So therefore, we have presently deterministic and linear extrapolation, but the very important question is how will the cell grow, intensify, or decay and become smaller? And that is not yet included. That is what is one purpose of the SINFONY project. So here you have also by using ensemble forecasts, you can derive probabilities. Here, for example, more than 35 dBz. So that is a first hint to a significant convective cell. And for the real and more intense cell, we have the threshold 46 dBz. And here, what I've explained already, the ensemble can be done here by variation of NWP wind in 700 to 500 hectopascal among 40 members. The tests are partly done also with only 20 members in order to save some computer time. So now I would like to explain how to consider the uncertainty of forecast. So what you see here in principle is the following. Here that is the measurement, and then you can have different scales. For example, if you have k equal 1, then you have a scale of 1080 kilometers. You will have more or less here a maximum, not similar to this one, but you can also then increase the number, and then you have better horizontal resolution, and then here 6 and 15, and you see more small scale features. And the question what is now to be answered is till which number of k is a forecast possible, and for higher k numbers not possible. And there is a dependency in the forecast time. For example, if you have now I have it. So let's say plus 5 minutes. Then you can take all these wavelength, these images, and you have, it's just an imagination. 10 minutes, you are not able to forecast here for very small scaled convective cells. So let's take here, then this is not possible. And let's say 20, that is not possible, and so on. So what is left here up to 30 minutes, you can use this here. And you will see afterwards that the extrapolation becomes smoother. So now, how is the ensemble done? We have seen that from for longer forecasts, it is not possible to do. I go back. It's a little bit unusual, inconvenient here. Okay, 30 minutes I have said. Up to 30 minutes. You take. So that is a random generated noise what is here taken. So you took that out, and then you put this one to the analysis, was measurement. This one means measurement, difficult to read. So in other words, I go back, and then you will see what is done. Here, these 4 fields are replaced by these 4 random generated noise. And then this random generated noise is a little bit changed 40 times. And so you will get the random generated perturbations. That is the idea behind this. So with other words, now here as when you consider the predictability, you see at the beginning more rough structures, but with increasing forecast times, very difficult to read here. Sometimes here's the time, yeah. You see it is becoming smoother. And that is a very important purpose for forecasters not to be confused. You see also here, just the beginning, please consider here this area. Now, yeah, very small features, and then they are removed because they are not predictable. So that is a very good feature. And then the ensemble is done by superimposing the random generated noise. So that is, I hope you have understood, yeah, more or less in principle what is behind that. So that is the upper minus lower quartile. Yeah, so the uncertainty can be also seen here in that way. Or here you have an area-based nowcasting. I will do it a little bit faster. You have here different members. Members here 0 means that is deterministic, but then we have here different nowcasting members. And if you consider all, then you can derive, for example, probabilities for exceeding a threshold, for example, 5 millimeters precipitation within 1 hour or so. Yeah. Yeah, here is it. Yeah, more than 19, or more than 35, or more than 46, and it is difficult to read. Yeah, at the beginning you have a high probability of exceeding. Yeah, here 46, but then it is becoming uncertain, and the small scale structures are removed. So you can also see that such probabilities can be forecast for up to maybe 30 or 60 hours, but then it has become less probable, and you cannot be so sure. So 35 dBz is not so important. Yeah, and other example here, some probabilities of high precipitation, more than 5 millimeters per hour. Yeah, and you can also see there's more smoothing as longer the forecast time becomes. And then can also interpolate in between steps of 1 minute if you are interested in this. Yeah, and another thing is and on development, I have almost forgotten to mention it now. We have also polarization radar, and so it is possible to derive the different precipitation types better, in a better form. Hail or snow, but here hail is the main point, summer convection. And then you can also adapt the so-called ZR relation also for each class. And so the developers in the research department tries also to adapt this by finding an optimal ZR relation for different situations, heavy thunderstorms, for example. You need another ZR relation if you have hail. If you have only normal rain, I would like to say, then you need another ZR relation. So we have a set of different relations for the different situation, weather situation, and for the different convective cells. So yeah, I will jump a little bit over it because I have still 7 slides left. So there are different examples. And so here you see also a single cell here, and so that is relatively good forecast, but there are even jumping between the different ensemble members, so the probability to have here a higher precipitation might be relatively low. So, and then here again, similar probability of more than 36 dBz, and then the spread is very important. Yeah, you have a kind of scattering between the different ensembles, how certain they are, and if as higher, as more uncertain is the forecast. And that is based here upon the noise overlaying and so yielding different members of ensemble forecast. So cell objects already explained. First, you have to distinguish from surrounding areas, for example, by considering DBZ gradients of DBZ values. If there's a strong gradient, so the cell should be at the end, at the edge of the cell. Then, therefore, we have here also different attributes, characteristics. There's a position. Then movement, speed, and direction. These are the attributes of the cell as a shape. Then the horizontal and vertical extension done by three-dimensional measurement of the radar systems. Lightning rate, there is a relation to derive this, but very uncertain. Is there rotation derived from Doppler radar images? And then it can be also combined and gets an intensity level 1, 2, 3, 4 in our service. And then we have here the three-dimensional control system. How that is done can you see now here in the next slide. Sorry. We have here two adjacent radar locations as an artificial image here, and only explaining the principle. And if here is an overlapping of two cones here, for example, then the following is done. The question is, where is a target? And then in relation to the angle and the distance to the radar location, the height of this target is also estimated. So, and if somewhere here in the upper level or even lower level or in the middle level, a target is detected, then the cell is marked. However, clear is at least in one level, of course, but you need also to exceed a threshold value, normally here in our service 46 dBz, but that can be slightly changed, of course, also depending where you are living. And because you take also this here or this alone, you have a better consistency. The two-dimensional Conrad, so is it called, has a problem that the cells are jumping and the forecasts are very much spreading from each to the from the one forecast time to the next one. So the consistency is relatively low. And then the cell attributes are evaluated, for example, risk of hail, maybe here high DBZ values, not so high here near the ground. That is a hint of cell intensification, and maybe later on, if the hail is here, more or less you have the hail at the ground. One example how that can be done automatically. So now Conrad two-dimensional, that 2D is missing here. And you see here the jumping forecast is also done a little bit, but you have also more distinguishing, separating of the cells, but the forecast is a little bit more stable. But it is not ideal. And what you see here, that is the old position, and here is the forecast position and the move direction. The movement direction is derived from not only two cell positions, they are more, and there is also that you will see later on statistical correction in form of Kalman filtering, what I will explain at the end of the presentation. So left you see not so stable as you on the right, but also not ideal. It's also jumping. And therefore, you need estimation of where will the cell probably be, And what is done, I cannot stop it unfortunately, is that you have here, that is the history of the cell positions. Then you have the forecast of cell positions. And then there is comparison between the history cell positions of the measurements and then the forecast cell, and then a probability according to the Gauss distribution is derived where the cell will be, let's say, in 1 hour or so. Yeah, and you can see that the area of the possible cell position grows and decays, yeah, depending in the results of the last forecasts. Yeah, here very uncertain, you can forget it. Yeah, but here is a second one, and it is becoming bigger sometimes, yeah, and a little bit smaller. Yeah, so that is no ensemble forecasting, only based upon tracking and Kalman filtering, and based upon historic cell positions and the forecast, and then the future cell positions are forecasted. And you see here sometimes the difference of the forecast and then the measurement, the black positions. So last overlay is now the the development, the cell growing and the cell decaying. That's what you here see is a climatology from 10 years based upon cells over Germany. And here you see the cell age in minutes, and here the cell size of areas with reflectivity of more than 46 dBz and in square kilometers. And what you can see in principle is the cell start is developing, and then it is growing, arrive at a maximum, here in this case 60 square kilometers, and then decaying again. And after about 100 minutes, it is more or less dissolved or very small. So that is the base what has been considered in order to overlay the forecast also with the developing of cells. That means growing and becoming smaller. And that is here more or less explained. What is done, and you will see it on the next slide, you create an ensemble of first guess parabolas. You will see in the next slide, and I can explain it better. And then during the forecast, the correction is done by using Kalman filtering. And then what is done later is to have a better mathematical approach. And I think I should take the next slide. That is what is behind mathematical approach based upon the climatology. So that is an artificial cell development. You have here the cell age, 0 to 60 minutes, and then here cell area. So, and here is a formula. You have from the climatology the A max, that is the maximum area. Here in this case, 50 kilometers, square kilometers, sorry. And then you have the lifetime, what you can take here from the climatology, maybe here 50 kilometers. You are more or less so 90 or 100 minutes. It's a little bit longer here in this case, shorter in this case. So, and this is known from the climatology here and here. And then you can slightly play with these parameters a little bit. Yeah, you have an Amax, you have a T and tau lifetime, and then you can calculate the area independent of the forecasting of the developing time. So it's growing, maximum, and decaying. So that is the idea behind that. And then, in order to have an ensemble forecasting, you can change it a little bit. Yeah. So that is is still in testing to play a little bit with the mathematical approaches to to describe such an cell development, growing and decaying in relation to time and to the cell area. So that is for second last slide. What you see here is here in the bottom. The green are the measurements. Then the black is the previous analysis, and you can see that the analysis is not identical with the measurement, because there are also some weighting function in it. There's also considering how good is the measurement, for example, and then you see here the analysis and the correction of the analysis in relation to the measurement in green is done by Kalman filtering. So now we come here again to the beginning. So here at the beginning you saw very, very wide spreading, because the parabola, the parameters are changed very much, but during the forecast time, Kalman filtering is working, and then you can see that the cells are developing in the different members of the ensemble forecast more or less in a similar way. That is a good case here, by the way. You will see afterwards in the last slide a very bad one. And so it is more becoming consistent. Where is the cursor? Here. You see a lifetime of more than 2 hours or so, difficult to estimate, is possible, but also shorter lifetimes. Here you see the spreading of the lifetime and also a spreading here of the cell area. That is the uncertainty, and here that is here the same for different cells here in a bigger region here of within Germany somewhere. So that is presently in testing. And the last slide is now a very bad case, and you can see that the forecast did not care here about the measurement, because it is assumed in relatively high uncertainty. And second, the Kalman filter has to be improved by some way. So that they do not know why this worked so badly, and that is a worst case. So you see there is something to do, but the idea is very good. We have now an ensemble by considering the cell positions, then also an ensemble by considering the cell growing and the self-decaying. And we have also a limitation to structures that can be forecast by smoothing the area and excluding more or less randomly forecast small scales. So I hope it was not exhausting for you, and that's for my side. And next slide, next presentation will be given together by Uli Blachak and myself. We plan it for mid of June. Thank you for listening.
We have a question for now.
Yeah, I am looking here on the. I hope you can.
Posting it in the chat.
Yeah.
From Ikene.
How do you generate radar nowcasting ensembles? You do it by measurements, and then when you perform the forecast, you have, for example, you consider Conrad the possibility to change a little bit the conditions for saying that is a convective cell. How is the horizontal gradient to define the edge of the cell? How do you define the center of the cell? That is presently done by adding the different position vectors and weight them with the DBZ values and divide it through all DBZ values. So you can change several things. What you can then do is when you go into the forecast, that you consider what is predictable in principle, and so you can remove very small scaled features in the forecast and replace them by random generated noise. And then the random generated noise is a little bit changed, is played with it. And so you have 40 fields and different random generated noise for performing the nowcasting or ensemble nowcasting based upon radar. So I try. Did you carry out verification of your nowcast chain? Yeah, in principle, yes, but I have to guess that I cannot tell you the results. But verification is always a very important part of developing. So I have shown to you a slide. I try to find it. I hope it will be not too slow. So yeah, there is it. Good. And I put it here on the left side and will share the screen. So my desktop one. So okay. So here you see verification. Yeah, but I cannot say how it is done. One possibility is, for example, to perform correlations, coefficients between measurements and corresponding forecasts. That is one idea what you can use. Then you can also evaluate the cell attributes, the size, the form, then the maximum DBZ value, connected weather situation, for example, is there hail, precipitation per hour. But it is relatively difficult to verify because you do not have at every place a surface observation or measurement. So you need, again, radar measurements, and the derivation of precipitation from radar is also, again, not very certain. Yeah, it is doing, but not clear how it is done, and I do not know the results. You have seen one bad example and one good example, and that is done step by step. So, skill score against raw model. What is a raw model? That is my problem. What do you mean with this?
Should I unmute? I don't know.
I read here the chat. Yeah, webinar is available later. I hope it is recorded. Tomislav?
Yes, it will.
Okay.
It will be available later today.
Okay, fine. Okay, then generate radar nowcasting is done. I hope this question was more or less okay. Use raise a hand option under participant list or was question in chat. Okay, that is not so. Did you carry out verification is done. Then skill score against the raw model. I'm wondering what is behind this raw model. So, and then thank you. And so I had to.
I have unmuted Lionel.
Yeah, somebody. Yeah.
Do you hear me? Yeah, raw model would be icon, I guess, for you.
Okay, that is. The skill score of the icon models in relation to summer convection, I have to guess, is relatively low. It's not bad. And the Cosmo D2 is able to simulate particularly convective cells, so that is an advance. That isn't. But the verification is not perfect.
So my question would be the skill score. That is,
skill score. So the skill
better
score.
you would be than icon.
Better than icon.
Yes.
The nowcasting, the forecaster. Or
Exactly. Yeah.
yeah. Now I understand. Yeah.
So you enhance icon forecast with your system.
Yes, the forecaster is already, especially during convective situations, improving the raw model output. So the problem what the model has presently is that the forecast is started, let's say, 3 hours before. Then, when you consider convective cells in model forecast, the position and also the intensity is rather uncertain. You will get only a hint. There will be some convective cells available, but the region, the location, and also the details are very uncertain. And so far, the forecaster improves the guidance from the model. And that is the reason why we try to improve also the model runs for doing the first 3 to 6 hours by also incorporating nowcasting parts, then to start the model more often every hour in order to reduce the principal problem what convective cells bring to modeling. So the forecaster is really very much improving the guidance from the model. Therefore, we have forecasters. Yeah, that is the reason. What's your question?
Partly.
Partly, yeah. Yeah, okay, yeah, thank you. If you have other questions, you can also send an email, and sometimes maybe I have to forward this to Ulrich Blachak. He's the expert, yeah. But I do my best, yeah.
Thank you.
Yeah. Okay.
There was a question from Xavier. I will post it in the chat.
Yeah, and maybe that I have already answered. I browsed here through the chat. And
1 second.
yeah. So I have a generator nowcasting sample. I try to answer.
From Xavier.
Is it one of the last ones here?
Yeah. Will this become?
Okay, I see. Become in the future collaboration open source European project similar to PySteps. I think I assume yes, yeah, that there also an European cooperation, but is also a question to Ulrich Blachak. He is a project leader, but I would be very astonished if it would be not a collaborative, because we are, yes, now I remember something. We some of these techniques are based already of some developments here in the UK or also Bureau of Meteorology in Australia. I should mention this. So that was a basic step. Yeah, they developed something in this area already just after 2000, and that was a starting point of this here SINFONY for improving it, for including this. So there is a cooperation, of course, and a connection to other services. But I do not know details. If you are interested, then you can ask Ulrich Blachak. I can just repeat the things, the share my desktop, and so just a moment. So here, that is the address, yeah. If you are interested in international cooperation, what is planned there. Or you can wait, if you have the time, till mid of June, then you can answer directly. So that are the two possibilities, but presently Ulrich is on holiday, so you would have to wait a little bit. So, other questions? So that seems to be in principle all.
Can you hear me? This is Oliver. Okay. Wait a second. Is it now better?
No.
Okay.
Yeah. So all are awakened again. Yeah, thank you. Wow. Yeah, very good.
I have muted him.
Yeah, it's okay. Fine. So then I have only to say thank you very much and for your patience. Yeah, and I hope I was able to transfer it a little bit to you. The main work was done by Ulrich, and he coached me as best as possible. So the recording is available. I see in the meantime 52 attendees. Wow, I can say again. Nice day for you. And I relate to the next part from DWD, mid of June probably, but I hope to have also the possibility to listen to other services, KNMI and so on here during the next months. Thank you, Tomislav, for preparing this session, and thank you to all of you.